that so the moment of inertia of the rectangular lamina about an axis passing through the center and parallel to its length can be calculated using the same logic that we calculated the expression for the moment of inertia. So parallel to passing through the center and parallel to the length. Sorry, parallel to the breadth. The same procedure if we follow, then so we are going to get the expression for moment of inertia about an axis passing through the center and parallel to length is I subscript b is equal to mv square by 12. You need not have to calculate expression for the moment of inertia explicitly once again for this second case, B case, because this case is similar to the first case. In the first case, axis, so that was actually passing through the center and it was so parallel to the breadth. Now here in the second case, so the same axis actually passing through the center, but with a small change that it is actually parallel to the length. So therefore, using the same logic, we can prove that the moment of inertia comes out to be mv square by 12. Okay, so therefore I can conclude. So moment of inertia of a so rectangular it is about an axis through the center parallel to the length is IB, because this moment of inertia is no longer a function of L, it is a function of breadth B, so that's why they are writing it as IB, and this comes out to be mb square by 12. ಈ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಒಳಗಡೆ ಸೊ ಬಿ ಎಲ್ ಅಂತ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಬರೋದೇ ಇಲ್ಲ, ಹಾಗಾಗಿ ನಾವು ಸೊ ಬಿ ಅಂತ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಮಾತ್ರ ಬಂದಿರೋದ್ರಿಂದ ಮೊಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಐಬಿ ಅಂತ ಬರ್ಕೊಂಡಿದ್ವಿ. ಸೊ therefore this moment of inertia IB is equal to mb square divided by 12. Okay, how do we calculate? Using the same logic. So I need not have to do it, ನಾನು ಅದನ್ನ ಮತ್ತೆ ಮಾಡೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ, ನಾನು ಮಾಡೋದು ಇಲ್ಲ. Using the same logic you can prove this. Okay, and the respective radius of gyration is very simple. So the respective radius of gyration is square root of b square by 12. Square root of b square is b, square root of 12 is 4 root 3, square root of 4 is 2, so therefore it is 2 root 3. So therefore the respective radius of gyration of the rectangular lamina about the same axis means axis passing through the center and parallel to the length is given by b divided by 2 root 3, where b is the so breadth of the disc. Okay, now this got aita.
Yes, sir.
Okay, now we want to calculate moment of inertia about the third axis. Third case, C case anta discuss madbeko. Now we discussed a case where moment of inertia, we calculated moment of inertia parallel to length. Sorry, parallel to breadth first and then parallel to length. Then I want to calculate moment of inertia about an axis passing through the center but perpendicular to the plane. Okay, can somebody say what is the thing I can use? What is the rule I can use to calculate moment of inertia of a so rectangular disc about an axis passing through the center and perpendicular? Last case of parallel to breadth, parallel to length ಅಂತ ತಗೊಂಡಿದ್ದಾನ, ಎರಡು ಕೇಸಲ್ಲಿ ಕೂಡ ಎರಡು ಆಕ್ಸಿಸ್ ಡಿಸ್ಕ್ ಮೇಲೆ ಪಾಸ್ ಆಗ್ತಿತ್ತು. ಬಟ್ ಇವಾಗ ಥರ್ಡ್ ಕೇಸಲ್ಲಿ ತಗೋತಾ ಇದೀನಲ್ಲ, ಈ ಕೇಸಲ್ಲಿ ಸೆಂಟರ್ ಮೂಲಕ ಪಾಸ್ ಆಗ್ತಿದೆ ಆಕ್ಸಿಸ್, ಅದ್ರ ಡಿಸ್ಕ್ ಗೆ ಪ್ಯಾರಲ್ ಆಗಿಲ್ಲ, ಡಿಸ್ಕ್ ಸರ್ಫೇಸ್ ಗೆ ಪ್ಯಾರಲ್ ಆಗಿಲ್ಲ, ಡಿಸ್ಕ್ ಗೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿದೆ. So therefore, how can I calculate moment of inertia of a circular disc, sorry, rectangular disc about an axis passing through the center and perpendicular to the plane? That means here in the diagram, so the axis is towards us or away from us. It is actually perpendicular to the plane of the diagram. Okay, so how do we calculate such a moment of inertia? Can somebody say quickly? So therefore, in order to calculate moment of inertia about an axis passing through the center and perpendicular to its plane, we make use of so perpendicular axis theorem. So therefore, we can say that moment of inertia passing through the center and perpendicular to the plane, I have written it as IC. IC, that is about your z-axis, that is z-axis. So therefore, this becomes IC. IC must be equal to moment of inertia about x-axis, L antana karkona, so it is IL, and plus moment of inertia about y-axis, adana parallel to breadth anta tagondiro case adu IB agutte. So therefore, it is IL plus IB. So IZ must be equal to IX plus IY, or IC must be equal to IL plus IB. Where IC is the moment of inertia through the center perpendicular to the plane. IL is so moment of inertia passing through the center, so parallel to length, and IB is the moment of inertia passing through the center and parallel to the breadth. Alva. So therefore, this moment of inertia IC must be equal to, one is ml square by 12, another one is mb square by 12. So therefore, m and 12 are common. So therefore, I can write this as m times l square plus b square divided by 12. So this is what one simple expression for the moment of inertia about an axis passing through the center and perpendicular to the plane. So it is m times l square plus b square divided by 12. And how do you find out the respective radius of gyration? Respective radius of gyration is very simple. It is square root of L square plus B square by 12. Square root of L square plus B square is square root of L square plus B square ಆಗುತ್ತೆ. Square root of 12 is 4 root 3. So therefore, 4 is 2. Square root of 4 is 2 ಆಗುತ್ತೆ. So therefore it is 2. So therefore the respective radius of gyration is KC, and that comes out to be equal to square root of L square plus B square divided by 2 root 3, where L is length of the disc, B is breadth of the disc. Okay na?
Yes, sir.
So shall we proceed then?
Yes, sir.
Yes, now we want to find out moment of inertia of a solid sphere. So solid sphere is now a 3-dimensional object. So far we discussed moment of inertia of a circular disc, annular ring, rectangular disc, and all those were actually examples for plane objects, 2-dimensional objects. So from 2-dimensional objects they are moving to one special case, 3-dimensional object. A 3-dimensional object is solid sphere. Solid sphere ಅಂತಂದ್ರೆ ಅದು ಸ್ಪಿಯರ್ ಒಳಗಡೆ ಎಲ್ಲ ಖಾಲಿ ಇರಲ್ಲ, ಒಳಗಡೆ ಎಲ್ಲ ತುಂಬಿಕೊಂಡಿದೆ. For example, so approximately earth can be treated as a solid sphere. Okay, in such a case, ಅಥವಾ ನೀವು ಕಿತ್ಲೆ ಹಣ್ಣು ಅಂತ ತಗೊಳ್ಳಿ, ಅಥವಾ ಯಾವ್ದಾರೋ ಒಂದು ಹಣ್ಣು ಸೂಟಬಲ್ ಮೂಸಂಬೆ ಹಣ್ಣು ಅಂತ ತಗೊಳ್ಳಿ, ಸೇಬಣ್ಣು ಅಂತ ತಗೊಳ್ಳಿ. ಐ ಮೀನ್ ಮೂಸಂಬೆ ಹಣ್ಣು ಕಿತ್ಲೆ ಹಣ್ಣು ತಗೊಂಡ್ರೆ ಅದು ನಿಯರ್ಲಿ ಅದು ಸ್ಪೆರಿಕಲ್ ಶೇಪ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. ಅದ್ರ ಒಳಗಡೆ ಮೇಲ್ಗಡೆ ಸಿಪ್ಪೆ ಇರುತ್ತೆ, ಬಟ್ ಸಿಪ್ಪೆ ಒಳಗಡೆ ಹಣ್ಣು ಇರುತ್ತೆ, ಖಾಲಿ ಇರಲ್ಲ, ಟೊಳ್ಳಾಗಿರಲ್ಲ. We are not talking of empty spherical shape. We are talking of solid sphere. Solid sphere in the sense inside there is matter. Okay, gottaita? So such a thing is what we call it as solid sphere. And solid sphere is an example for 3-dimensional object. Okay na?
Yes, sir.
Okay, now this whatever the circle I have written, see, please remember this is a solid sphere. The solid sphere is 3-dimensional. I cannot represent a solid sphere on the plane. I can only represent solid sphere with the help of a circle. The circle ಬಂದಿದ್ದೀನಿ ಇಲ್ಲಿ. So you should not assume that it is a disc. The disc ಅಲ್ಲ, circle ಅಲ್ಲ. It is basically a 3-dimensional solid sphere. I cannot represent 3-dimensional solid sphere. So on the 2-dimensional plane, I can only write a circle. So therefore, this is circle. Whatever I have written, it actually represents a solid sphere. So first, I want to calculate moment of inertia of this solid sphere about an axis through the diameter. Through the diameter means, so I am trying to calculate moment of inertia about an axis passing through AB. AB is one diameter. There are several diameters, of course. AB is one diameter, and I am assuming that the axis is actually passing through AB diameter itself. So therefore, with respect to the axis which is passing through the diameter, we are interested to find out the moment of inertia. Okay, na? So in order to calculate moment of inertia, we require certain things. So let us assume mass of the sphere as capital M, radius of the sphere is capital R. So volume of the sphere is very simple, 4/3 pi r cube. Correct?
Yes, sir.
Since it is a 3-dimensional object, since this is a sphere, it has a volume. So its volume is 4/3 pi r, where a capital R is the radius. Okay, na? And it is also possible to calculate the density. Density of the sphere rho, symbol for density is rho. So density of the sphere rho is given by mass by volume. Mass is capital M, volume is 4/3 pi r cube. So in 3 there are numerator root over there. So therefore rho becomes 3m divided by 4 pi r cube. So the density of the sphere comes out to be 3m divided by 4 pi r cube. Where m is the mass, r is the radius. And we are assuming that the density of the sphere rho is a constant. We are assuming this is a sphere of constant density. Sphere of constant density ne irbeku anta enilla. We can also discuss a case where density is changing. But density change ಆಗ್ತಾ ಇದ್ರೆ ಆ ಕೇಸ್ ಅಲ್ಲಿ moment of inertia calculate ಮಾಡೋದು ಕಷ್ಟ ಆಗುತ್ತೆ. That's why we are avoiding that case. We are going for a special case where we are assuming that the density of the sphere is constant. Density of the sphere is constant means rho anta ಬರ್ಕೊಂಡಿದ್ದೀವಲ್ಲ, rho is constant. Rho is not changing. If rho is not changing, so rho becomes constant. So therefore this is what we get as a constant density sphere. Okay na? ಗೊತ್ತಾಯ್ತಾ ಇದಿಷ್ಟು?
Yes, sir.
Okay, now listen to me very carefully. So I am taking one small section of the sphere. Okay, and that small section of the sphere is written as PQRS, PQSR or PQRS, whatever. PQSR is a small section of the your solid sphere, which is taken by taking a cut at one of the edge. ಇಡೀ ಸ್ಪಿಯರ್ ಏನಿದೆ, ಇಡೀ ಸ್ಪಿಯರ್ ನಲ್ಲಿ ಯಾವುದೋ ಒಂದು ಸೈಡ್ ಅಲ್ಲಿ ಏನ್ ಮಾಡ್ತಾ ಇದೀವಿ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇದನ್ನ ಹಣ್ಣು ಅಂತಾನೆ ತಗೊಳ್ಳೋಣ. ಲೆಟ್ ಅಸ್ ಅಸ್ಯೂಮ್ ಇದು ಯಾವುದೋ ಒಂದು ಸ್ಪೆರಿಕಲ್ ಶೇಪ್ ಅಲ್ಲಿ ಹಣ್ಣಿದೆ. ನನ್ನ ಹತ್ರ ಒಂದು ಚಾಕು ಇದೆ, ಆ ಚಾಕುನಲ್ಲಿ ನಾನು ಏನ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಯಾವ್ದೋ ಒಂದು ಸೈಡ್ ಅಲ್ಲಿ ಮಧ್ಯಭಾಗದಲ್ಲಿ ಒಂದು ಬಿಲ್ಲೆ ತರ ಹೆಚ್ಚುತ್ತಾ ಇದ್ದೀನಿ, ಒಂದು ಬಿಲ್ಲೆ ಅಥವಾ ಒಂದು ಚಿಕ್ಕದಾಗಿ ಹೆಚ್ಚುಕೊತೀನಿ. ಆ ಚಿಕ್ಕದಾಗಿ ಹೆಚ್ಚುತ್ತೀನಲ್ಲ, ಸೊ ದಟ್ ಸೆಕ್ಷನ್ ಇಸ್ ಯುವರ್ PQRS. Now can somebody say what is the shape of this section PQRS? It is circular disc because it is taken from the sphere, so therefore it is circular in shape and it has a small thickness. PQ and RS ಮಧ್ಯದಲ್ಲಿ thickness ತುಂಬಾ ಕಡಿಮೆ ಇದೆ, so therefore since small thickness ಇರೋದ್ರಿಂದ ಪರವಾಗಿಲ್ಲ, no problem. It is a two-dimensional object, nearly a two-dimensional object. Since it is taken from one of the section of the sphere, therefore it must be circular. A circular thing, so in which there is a matter everywhere continuously, the small thickness is what we call it a circular disc. So therefore the shape of the shape of the portion PQRS is a circular disc. ನಮ್ಗೆ ಈ ಕಡೆ ರೈಟ್ ಸೈಡ್ ಇಂದ ನಾವು ಫ್ರಂಟ್ ಇಂದ ನೋಡ್ತಿರೋದ್ರಿಂದ ಇಟ್ ಅಪಿಯರ್ಸ್ ಒಂದು ಥಿನ್ ಸ್ಟ್ರಿಪ್ ತರ, ಒಂದು ವರ್ಟಿಕಲ್ ಆಗಿ ಪೇಪರ್ ಶೀಟ್ ಇರುತ್ತಲ್ಲ, ಟೂ-ಡೈಮೆನ್ಷನಲ್ ಪ್ಲೇನ್ ತರ ಕಾಣುತ್ತದೋ, ಬಟ್ ಇಟ್ ಇಸ್ ಆಕ್ಚುಲಿ ಫ್ರಂಟ್ ಪೋರ್ಷನ್. ಸೊ therefore ನೀವು ಆ ಕಡೆ ಅಡ್ಡ ನೋಡಿದ್ರೆ, ನಿಮಗೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಂಗಲ್ ಇಂದ ಅಥವಾ 90 ಡಿಗ್ರಿ ನಲ್ಲಿ ನೋಡಿದ್ರೆ ಇಟ್ ಅಪಿಯರ್ಸ್ ಟು ಬಿ ಎ circular disc. So therefore I want to say this small portion, the small section of the solid sphere PQRS, although it appears like a rectangle, ಇಲ್ಲಿ ಫ್ರಂಟ್ ಅಲ್ಲಿ ನೋಡಿದ್ರೆ rectangle shape ಕಾಣಿಸುತ್ತೆ, but it is not rectangle, it is a spherical, sorry, it is a circular disc. PQRS is a circular disc because this whole thing is a three-dimensional sphere. A section in the form PQRS would definitely give us a circular disc. Okay, so PQRS is a circular disc. So for this circular disc, so radius is actually not good. So from O to this particular point, so from the center of the sphere O to the one of the edge disc edge tagondre, so that distance we have taken it as x, and that this distance OP is nothing but radius. So therefore using your Pythagoras theorem, so this is hypotenuse side r square must be equal to, illೊಂದು ಇರಬೇಕಿತ್ತು, ಇಲ್ಲೊಂದು ಲೆಟರ್ ಮಿಸ್ ಆಗಿದೆ, ಬಟ್ ಪರವಾಗಿಲ್ಲ, ತೊಂದರೆ ಇಲ್ಲ. r square must be equal to x square plus, so small ಇದು ಈ ಪಾಯಿಂಟ್ ಇಂದ ಹಿಡಿದು p ಅಂತ ಇದೆಯಲ್ಲ ಆ ಪಾಯಿಂಟ್ ಗೆ, ಸೊ ಅದು ದಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಯುವರ್, ಸೊ ಸ್ಮಾಲರ್ ಆಗುತ್ತೆ, ರೇಡಿಯಸ್ ಆಫ್ ದ ಸರ್ಕ್ಯುಲರ್ ಡಿಸ್ಕ್ ಆಗುತ್ತೆ. ಸೊ ರೇಡಿಯಸ್ ಆಫ್ ದ ಸರ್ಕ್ಯುಲರ್ ಡಿಸ್ಕ್ ಮಸ್ಟ್ ಬಿ ಸ್ಮಾಲ್ r square ಅಂತ ತಗೊಂಡ್ರೆ r square, capital R square must be equal to x square plus small r square. So therefore small r square must be equal to square root of r square minus x square. So therefore I can say that PQRS is a circular disc, and this circular disc is having a radius of square root of r square minus x square. Okay, ಗೊತ್ತಾಯ್ತಾ ಇದಿಷ್ಟು?
Yes, sir. Yes, sir.
Okay, see, that is what I have written. Consider a thin circular slice. Since this is a thin circular slice, so therefore this is a circular disc of the sphere at a distance x. So this is ಈ slice ಗೂ ಮತ್ತೆ center of the sphere ಗೂ ಇರೋ distance x ಆಗುತ್ತೆ. So that's what I have written, at a distance x from the center O, and the thickness is dx. So this slice is a circular disc of radius square root of r square minus x square and the thickness. Okay, so therefore thus this slice PQRS is a circular disc of radius square root of r square minus dx, sorry, r square minus x square, and the thickness of this andre PQ ಮತ್ತೆ RS ಇದೆಲ್ಲ ಎರಡರ ಮಧ್ಯದಲ್ಲಿ ಇರೋ ಗ್ಯಾಪ್, ಅದನ್ನ dx ಅಂತ ಬರ್ಕೊಳ್ಳಿ. dx is the thickness of the slice, thickness of the circular disc. Okay, although it is two-dimensional, but still because of its small thickness, dx into thickness irodrinda, so therefore it has a volume also, and we are calculating area, volume, everything. So area of the disc is nothing but pi r square, pi times small r square, but small r is nothing but square root of r minus x square. So therefore r square becomes capital R square minus x square. So therefore area of the disc is pi times r square minus x square. ಗೊತ್ತಾಯ್ತಾ ಈ ಸ್ಟೆಪ್?
Yes, sir.
Okay, now although it is a disc, ಅದು disc ಆಗಿದ್ರು ಕೂಡ ಅದಕ್ಕೆ ಕಡಿಮೆ thickness ಇದೆ dx ಅಂತ, dx ಇರೋದ್ರಿಂದ it covers a small volume. So therefore volume of the disc is area of the disc pi times r square minus x square into thickness dx. So therefore volume of the small disc PQRS is pi times r square minus x square into dx. ಇದು ಹೇಗೆ ಬಂತು? It is area pi times r square minus x square into thickness. Thickness is dx. Now mass of the disc ಏನಾಗುತ್ತೆ? Mass of the disc is nothing but volume of the disc into density. Volume of the disc ಈಗ ತನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ವಿ, pi times r square minus x square into dx. So density is rho. Okay, so therefore this becomes equal to pi times r square minus x square into dx. Rho is agla helide nodi. So density rho is 3m by 4 pi r cube agutte. So therefore I have substituted here density rho is 3m divided by 4 pi r cube. You can do the simplification. Idana simplification madidre pi matra cancel agutte, ಏನು cancel ಆಗಲ್ಲ. So there we are left with 3m divided by 4 r cube. 3m divided by 4 r cube times r square minus x square into dx. So mass of the disk is actually, so mass of the small disk PQRS, disk anta barkondiddare PQRS slice idrardu mass enagutte. So the mass expression comes out to be 3m divided by 4 r cube. Capital M is mass of the sphere, capital R is radius of the sphere, minus r square minus x square into dx agutte. Actually we are not interested in the moment of inertia of the, so sorry, we are not interested in the mass of the disk, we are interested in the moment of inertia of this disk. So moment of inertia of this disk is delta I. This is not for the entire sphere, this is for the small disk. Okay. What is the expression for the moment of inertia of a circular disk about an axis passing through the center and perpendicular to its plane? So here the axis is AB. AB is an axis passing through this circular disk AB. PQRS antidella is circular disk alli AB axis pass ಆಗ್ತಿದೆ. AB ಯಾವ ತರ ಪಾಸ್ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಈ circular disk ಗೆ ಸೆಂಟ್ರಲ್ ಪಾಸ್ ಆಗಿದೆ ಮತ್ತೆ perpendicular ಇರುತ್ತೆ. ಆ ತರ ಇದ್ರೆ ಏನಾಗುತ್ತೆ? What is the expression? It is mass times radius r square divided by 2. This is the standard expression for the moment of inertia of a circular disk about an axis passing through the center. ನಾವು ಇಲ್ಲಿ ತಗೊಂಡಿರೋ disk PQRS ಕೂಡ circular shape ಅಲ್ಲೇ ಇದೆ. So ಹಾಗಾಗಿ the moment of inertia of this disk is delta I is equal to delta m, mass of the disk, into radius of the disk is smaller square. Okay, ಕೇಳಿಸಿದೆಯಪ್ಪ?
Yes, sir.
Okay. Sir. So the moment of inertia of this small disk PQRS is mass of the disk delta m r square by 2. Delta m into r square by 2 ಎಲ್ಲಿಂದ ಬಂತು? It is the standard expression for the moment of inertia of the disk. Okay, about an axis passing through the center, it is m r square by 2. But m ಜಾಗದಲ್ಲಿ ಇಲ್ಲಿ delta m ಬರುತ್ತೆ ಅಷ್ಟೇ. Okay, so therefore delta m is 3m divided by 4 r cube r square x square, r square minus x square into dx. 3m divided by 4 r cube r square minus x square into dx. Small r square is nothing but r square minus x square agutte. So therefore it is r square minus x square divided by 2 agutte. So I can do this simple calculation. So 2 multiplies with 4, it becomes 8. So therefore this becomes 3m divided by 8 r cube, r square minus x square, r square minus x square. So therefore it is r square minus x square whole square dx. Okay na? Now, so calculation is ಸ್ವಲ್ಪ ಜಾಸ್ತಿ mathematics ಇದೆ. So moment of inertia I of the entire solid sphere about an axis passing through the diameter is twice the integral of the above expression. Integration ಏನ್ ಮಾಡ್ತೀವಿ? Integration double ಮಾಡ್ಕೋಬೇಕು. Because if I do 0 to r ಅಂತ ಮಾಡ್ಕೊಂಡ್ರೆ it covers only half of the sphere. So if I do the integration starting from 0 center to the upper integral limit capital R, it actually encompasses only half of the sphere. But your full sphere is not half of the sphere, it is actually 2 times double the sphere. That's why in order to calculate the entire moment of inertia, I am doing this 2 ಅಂತ ಮಾಡ್ಕೊತಾ ಇದ್ದೀನಿ. ಈ 2 factor ಯಾಕೆ ಬರುತ್ತೆ ಅಂತಂದ್ರೆ, so because we are doing the integration part to 2 hemispheres. Okay, so there is a 2 integration 0 to r of the previous expression. In delta I ಅಂತ ಏನು ಬಂದಿತ್ತು already expression ಅಲ್ಲಿ substitute ಮಾಡಬೇಕು. 3m divided by 8 r cube r square minus x square whole square dx ಆಗುತ್ತೆ. So therefore, so integration of 3m divided by 8 r cube r square minus x square whole square into dx ಆಗುತ್ತೆ. So this 3m by 4 r cube ಆಚೆ ಬರುತ್ತೆ. Okay, so this 2 you can cancel with 8. So therefore this becomes 4. 3m divided by 4 r cube, and r square minus x square whole square is, so a minus b whole square formula ಇದೆ. It is a square r to the power of 4 plus b square x to the power of 4 minus 2ab 2 r square x square into dx. Okay, so and if you do the integration of r to the power of 4, can somebody say what is the integration of r to the power of 4? So r power of 4 constant, r to the power of 4 is constant, ಹಾಗೆ ಇರುತ್ತೆ. Integration of dx is x. Now we have x to the power of 4, integration of x to the power of 4 is x to the power of 5 divided by 5. X to the power of 4 plus 1 divided by 4 plus 1. X to the power of 5 divided by 5. Minus 2 r square constant ಹಾಗೆ ಇದೆ. We have x square term, integration of x square is x cube by 3. So therefore we have this term r to the power of 4 times x plus x to the power of 5 divided by 5 minus 2 r square x cube divided by 3, 0 to r. I have to substitute the lower limit and the upper limit. If I lower limit ಎಲ್ಲ ಕಡೆ 0 ಬರುತ್ತೆ ಬಿಡಿ ತಲೆ ಕೆಡಿಸ್ಕೊಳ್ಳೋಷ್ಟು ಇಲ್ಲ. If I substitute the upper limit, so r power 4 into r, it is r power 5. R power 5 x ಜಾಗದಲ್ಲಿ r ಹಾಕಿದ್ರೆ r power 5 by 5, r power 5 divided by 5. Then we have minus 2r square, r cube, x cube means r cube. So it is r square into r cube, it is again minus 2r to the power of 5 divided by 3. Okay, so then I is equal to, the first term is 3n divided by 4r cube. If you simplify this, ನಾನು ಮಾಡಿಲ್ಲ, LCM ತಗೊಂಡು ಮಾಡ್ಕೊಳ್ಳೋದ್ರಲ್ಲಿ ಏನು ಮಾಡಕ್ಕೇನು ಅಂತದೇನೂ ಇಲ್ಲ. Okay, so I don't know ನಿಮ್ಗೆ ಎಷ್ಟು ಜನಕ್ಕೆ ಇದು ಬರುತ್ತೋ ಇಲ್ವೋ ಅದು ಕೂಡ ನನಗೆ ಗೊತ್ತಿಲ್ಲ. But anyhow, if you simplify these three terms, you're going to get 8r power 5 divided by 15. So 3 5s are 15, 4 2s are, so 2 agate. So therefore r to the power of 3 you can cancel with r to the power of 5 here. So therefore this becomes r square. So therefore the moment of inertia of the entire sphere about an axis passing through the center and the diameter is actually comes out to be 2 by 5 times mr square. So 2 divided by 5 times mr square is the moment of inertia of the solid sphere about an axis passing through the diameter. The respective radius of gyration is, so m ತೆಗೆದ್ಬಿಟ್ಟು ಉಳಿದಿರೋ ಟರ್ಮ್ ಗೆ ಸ್ಕ್ವೇರ್ ರೂಟ್ ತಗೋಬೇಕು. So square root of 2 by 5 times r square, square root of 2 by 5 is 2 by 5, square root of 2 by 5, square root of r square is r. So therefore the respective radius of gyration is square root of 2 by 5 into r. r, so numerator ಅಲ್ಲಿ ಸರಿ ಸ್ಕ್ವೇರ್ ರೂಟ್ ಇಂದ ಆಚೆ ಕಡೆ. ಆಯ್ತಾ, ಇದಿಷ್ಟು ಗೊತ್ತಾಯ್ತಾ?
Yes, sir.
Yes, sir.
Yes, we'll do one last case. I think I will take another 1 or 2 minutes. I'm going to close it. We are going to go for the second case. We want to find the moment of inertia of the same solid sphere about an axis through its tangent. Through its tangent andre diagram na bardilla. Now I'm going to consider an axis here. Illi tagotini. So if I take the axis here tangential to here, this is an axis actually pass parallel to your diameter. So therefore, since I know the expression for the moment of inertia about the diameter, since I want to calculate through a tangent, so therefore I can use case of your parallel axis theorem. So therefore, according to parallel axis theorem, so moment of inertia about any axis must be equal to moment of inertia. So about center of gravity, moment of inertia about center of gravity is nothing but 2 by 5 times mr square into mass into square of the distance. Square of the distance between the diameter and the tangent is nothing but radius itself. So therefore, this becomes mr square. So 2 by 5 mr square plus mr square. You take, you mean LCM, and if you multiply 2 plus 5 is 7. It becomes 7 by 5 times mr square. Okay, and the respective radius of gyration is, of course, the square root of 7 by 5 times r.